Lesson 29. Lesson dealing with the unit circle. And it's basically, what we're referring to here is that when we make these reference triangles, they are the basic ratio. So like the 1, 2, radical 3 and the 1, 1, radical 2 is what you're dealing with. So we're dealing with basic single units on a coordinate plane, and then compare this to a unit circle, meaning that we're using 1 as our basic as we go around. We'll also look at very large and very small fractions and quadrantal angles. But for the most part, this is really what they give you. So you might see some other questions show up in your homework after we cover this, and I'll be more than happy to help you with those. But in terms of what it gave me for you to actually work out up here, this is what we've got. So a lot of this, yes, can your calculator do some of these? Yes, but anytime we end up with a radical answer, it's not going to convert that to a radical form for me. So we've got to be able to do this. So if we're looking at question number 1, let's go ahead and, well, I think we could probably do it right here. Okay, so sine of 150 degrees. So for every one of these, right, I'm going to have a separate coordinate plane. Okay? So for sine of 150, which quadrant does that put me in? Go counterclockwise from the initial side. Top left. Top left. 150 degrees is right there.
Oh, we go from the right side.
Yep. So we're here, okay? And we want to make that type of triangle, right? We always want to take our terminal side and bring it down to the x-axis, okay? So the next thing I need is that reference angle that we talked about a lesson or two back, right? What's the reference angle here? If it's 150, 180 minus 150, so my reference angle is 30, right? Which makes this 60, giving me a 30, 60, 90 right triangle. Okay, so what is opposite the 30? 1. What's opposite my right angle? 2. And then what's opposite 60? Radical 3. Now, because we're on a coordinate plane, what kind of radical 3 is that? It's a negative radical 3. Okay? So when we say sine of 150, we're referring to the sine based upon the reference angle. Okay? So based upon where my reference angle is, sine is what? Opposite over hypotenuse. So what's opposite my reference angle? 1. And what's hypotenuse? 2. So if you type in your calculator sine 150, does it give you 0.5? Probably be handy to have it. Okay, so we double checked it. We got the right thing. Okay? I probably want to check these things as I go wherever, if I come out with a nice, neat, clean answer, and then I type it in my calculator and I get the equivalent form, okay, at least I've done one part of this right, because we've got at least 4 parts, really more like 8 by the time I add and subtract these things all together, right? Okay, so now we have cosine 120. Okay, which quadrant is that going to put me in? Same quadrant. Okay.
Number 2, right?
Huh? Yes, because it goes 1, 2, 3, 4. Okay? That probably would have been clearer if I hadn't used Roman numerals. You're like, wait a second, I don't even know what that means. Okay. All right, so we're in the same quadrant with a 60-degree reference angle. Okay, so I'm still at a 30, 60, 90, but where those numbers go has now changed. All right, so opposite of my 30 is what? Negative 1. Very good. Opposite the 60 is radical 3, and opposite my hypotenuse is still 2. All right, we want cosine, but I'm no longer doing cosine of 30 degrees. I'm doing cosine of 60. Okay? I'm not using 30 as a reference angle. I'm using 60 as my reference angle. And except it's adjacent over hypotenuse. What's adjacent to 60? Negative 1, and hypotenuse is 2. All right. Now I'm going to carry down that plus sign and put it right there, because if that had been a subtraction, right, I would be adding 1/2 to 1/2. So don't forget the operations that exist between my trig functions. Okay. Now we're at cosine 270. We're going to have to remember something here. Where does cosine 270, where does 270 degrees exist at? No. On the line right here, right? And this is where the unit circle is important, right? Because, and I think we've talked about this. I think I gave you guys a bunch of information on this. What am I going to get? Cosine, right? Cosine represents what? Does it represent the x-axis or the y-axis? The x-axis. So what is the x value on the y-axis? 0. So I am subtracting 0 from it. Now, if I want to double check that, right, anytime it shows up on an axis, my answer is either 0, 1, or -1. Anytime I'm on an axis and I'm using unit circle, I'm 0, 1, or -1. So did cosine 270 equal 0? All right. Did cosine 120 equal, what did it equal? Was it -0.5? Okay, good. All right, so far so good. Now we're cosine 60. Okay, which quadrant am I in here? Cosine 60. First quadrant. Okay. What on earth? Leave me alone. Okay. It's going to be weird on the recording. You were in class with him? What was he talking about? Okay. So my reference angle is 60. We got 30. We got 90. Okay. I always go opposite 30 first. 1, and a positive 1 this time, right? Because we're to the right of the y-axis. Opposite is 60. Radical 3 and 2. Everything's positive in the first quadrant. It's the only quadrant where everything is positive. Okay? All right, so cosine from 60, 1 over 2. But be careful because we've got a negative there, right? So what happens to our first halves? They cancel out. We're subtracting 0 from it, so I'm simply left with -1/2. If I plug all of that in my calculator, sine 150 plus cosine 120 minus cosine 270 minus cosine 60, do I get -0.5? Great. Will it always work out that nice and neat? No, it won't. Okay? Okay? Now, here's the nice thing about these, is that really, once you've done one, right, like sine 150 will always and forever be 1/2. Okay? Always will be. Okay? Cosine 120 is always going to be -1/2. So at a point where you get to, you know, if there's enough repetition, or if, let's say, the second problem uses something from an earlier question, like, notice how we have cosine 60 here? Right? We know cosine 60 is 1/2, right? I don't have to do the coordinate plane again. Okay? Now, is it good practice? Yes. But if I did it right, the first time, right, it's going to be right the second time. All right, so let's look at this one. All right? Sine is the y-axis. Yes. Tangent, okay, yeah, it's a good question. What is tangent in a situation like that? Tangent is sine over cosine. Because it's opposite over adjacent, sine represents opposite because it uses opposite over hypotenuse. Cosine uses adjacent over hypotenuse. So your tangent function is sine over cosine. So if you wind up on an axis with and it's asking for tangent, right? It might be, because, you know, let's see, I don't know, let's pick it for instance. Let's say tangent 90, right? Okay, now that if we're talking about it. All right, what is the sine value at 90? It's 1, right? Right, what is the cosine value? 0. So I have undefined. So go ahead and type in your calculator tangent 90 and see if it doesn't give you an undefined value. Error, right? Error or undefined, can't do it, right? Whereas So tangent on an or tangent on any axis is probably going to be 0 or error, because let's say that we went with, let's say 180, right? Tangent, yeah, tangent 180 here. Well, the x-axis on that, or sorry, that would be what? 0 divided by -1, right? So you get 0. But that's your only two options with tangent on an axis is either 0 or error. Okay? All right.
If they gave you 120, you still use your reference.
Yeah, if they gave you tangent 120, you could still use a reference triangle. If it shows up really anywhere else, not on a line, tangent will be fine. Yeah.
So 90 and 270 are the same, but that's 180 and 0 or 360.
In terms of your tangent,
Yeah.
yes. Yeah, because you're going to get 1 or -1, but it's still 0 divided by 1 or 0 divided by -1. It's still going to be 0 or error. Yep. So good questions. Okay, so let's get into this. Sine 210. Now we're in a different quadrant this time, right? Which quadrant am I in? And I was, 90, 180, 270, 360, right? So kind of followed it around. Where am I at? Third quadrant?
Yeah.
Okay, so I'm there. Okay, my reference angle. How far past 180 did I go to get to 210?
70.
Huh? No. Don't mess with 270, right? Everything is in relation to the x-axis. So I'm at 210. That means I came around to, I came around to 180 and I kept going, right? How much further did I keep going? 30 degrees. Okay, so I'm at 30, 60, 90. Now, they're giving you all nice, neat, special right triangle stuff now. Eventually, things will change, okay? But just so we understand. All right, so now let's put in our ratios. Opposite of 30 is -1. 60 is negative radical of 3. And my hypotenuse is always positive. So in the third quadrant, my x and y values are both going to be negative, which can create an interesting situation in, let's say, in a tangent situation, third quadrant comes out positive because you're opposite over adjacent, so you're negative over negative. Your negatives are going to cancel out in a tangent situation in the third quadrant. I always like saying sentences like that because it makes me sound super smart. Like maybe he is solving time travel. I don't know. Okay? All right, so sine of 210. So we're basing it upon the 30. Okay? We want what? Opposite over hypotenuse. -1/2. Okay? And that's something we can check. All right? Let's go to sine of 180. Where's that at? On the axis right here. And because it says sine represents what? No. Well, the y-axis. So it's 0. 0 because it's not going up or down, right? It's 0. So we're minus 0. Okay? Are we getting it? We're okay? It really is going to take all hour to do 2 questions. Okay? All right. Cosine of 60. Well, we've been there before, right? Right here, right? We got this guy. We got, let's see, 60. We got this guy over here. We got this guy is a 1. This guy's a radical 3. This guy's a 2. Okay? Oh, it really sounds insulting whenever I put it that way. This guy's a 2. Okay. Let's see. And so we want adjacent over hypotenuse. What am I getting there? Yeah. It's not even a full number. But he's radical, so I don't know. If you're in like the 70s, 80s, that's cool at least. He's radical. He probably surfs. You get 1/2. Yeah, let's get back to the question. 1/2. If anybody's watching this online, oh, finally, there's a lesson on, on solving unit circle, and I'm going to watch this video. And they're like, what on earth is this guy talking about? This is not math related at all. How do these kids learn anything? The truth is that they don't. All right, 270. Where's 270 at?
On the y-axis.
Up or down? down.
Negative 1.
So negative 1 because we are down. If it had been sine of 90, it would be positive 1. Right? Because my 1/2s cancel out. 0 does nothing. Right? It's so lazy. Yeah, it's a negative 0.
Even worse.
You're not even 0. You're negative 0. Okay. So we can hit stop there. Let you guys work. I'll walk around and answer questions. Gives you about 14 minutes.